Hello all, welcome to our webinar on DevOps 101, Intro to Package Management. Today we'll learn really cool concepts around package management, binaries or artifact management, and we'll also dig deep into some of the cool concepts within it. First things first, a quick introduction about myself. This is Gautam Nirkonda. I'm working as a senior solutions engineer at JFrog. My role here is to talk to customers, understand what their DevOps initiatives are, and showcase how our JFrog platform can help them drive the automation around their DevOps workflows, and also making sure that they are aware of all the best practices, what other customers are doing in terms of implementing their containerization, digital transformation, and their DevOps journey altogether. This is where I come from. So coming to the agenda, we are going to cover the quick definition of DevOps and what it means to developers. And then we will dig deep into package management. What is a binary repository manager? Why do you need it? What are build artifacts, various components that are part of your build artifacts, and why do you need to manage them, right? And finally, we'll also switch to the demo unit and see some of the aspects of what Artifactory offers as a solution for binary repository management as well in the towards the end. Feel free to post your questions under the Zoom chat or the Zoom Q&A session box, wherein we can also try to address the questions as they come in, or I'll also try to make some time towards the end, the last 15 to 10 minutes for answering them as well. Now, let's look at what is DevOps. So you might have heard multiple you might have heard multiple definitions, but mainly, as I see it, DevOps is a set of practices that combines the developers and the IT operations team and bring them into one single common language of communication. Basically, the number of iterations that you perform before you deliver a software release varies between the type of methodology that you use. Traditionally, there has been waterfall and agile methods, but DevOps is picking up a lot of traction and becoming the center soul for software development in any organization nowadays. Now, when it comes to the entire DevOps implementation, there are multiple stages: planning, coding, building, testing, releasing it, and deploying it, and operating it, and monitoring it. The main entity that travels throughout the DevOps lifecycle stages is the actual binary, because you and your developers might have planned a given release and submitted the source code. But once the source code has been built, there are multiple stages through which the actual binary or the executable will be traveling through. And this is the single source of truth that actually gets executed in the runtime environment. So again, when it comes to onboarding the DevOps practices, automation is very critical because there are multiple repetitive tasks of creating a given build and then unit testing it, qualifying it through multiple functional, performance, and stability tests before it gets deployed into production, and post-deployment into the production as well. You might be monitoring the load and sizing the application accordingly. All of these tasks cannot be controlled by a human or like adjusted manually. That's where the main importance of automation comes in for a DevOps implementation. Now, what does it mean for developers? Making your code more modular so that every team member or groups of development teams can work on their own module and contribute towards their overall software application. This is the key, because everyone can run their own sprints or work on their own modules, and then unit test it before they integrate it, and finally make sure that the the features are released in increments or smaller iterations so that you can fail faster and make some modifications towards your software application. This is also will help you to avoid the frequency of bad releases. We have to agree to the fact that every software has a bug, and every software will incur a bad release at some point or the other, and making sure that you automate the process of reverting the release as soon as a given bug is detected or anomaly is detected, and iterate through the process of continuously testing and continuously integrating and continuously delivering the software is also going to be the key when it comes to the DevOps practice. Same way, it can be also looked in a sense that the breakdown of a monolith application into multiple microservices is also part of this transition. And as a developer, you might not be completely aware of the container technology, but it would be good to understand the concepts of Docker and Kubernetes and be aware of what they bring in as an advantage, especially with the modern digital transformation practices that are coming into the place. Again, there are certain other best practices as well. All in all, the DevOps practices for developers is a cultural shift altogether, and you need to be prepared to embrace this initiative whenever your organization takes it up, and be aware of all the best practices as they come in to make sure your teams are getting benefited from them. Now, what is package management, and how did it all started? Now, according to the Wikipedia definition, it basically means that a collection of software tools that can automate the process of installing, upgrading, configuring, and removing computer programs in a consistent manner. Now, traditionally, when you have a code, you will need to compile it, you will need to build a make file, and then make sure that all of the dependencies, configuration, and the environment that the given software needs to be in place before you actually run the actual software. But as software development practices evolved and the complexity of the software applications have evolved, the number of dependencies a given software application needs or your build needs has drastically increased. And in a way, you need to have a tool to automate the process of pulling down all the collection of dependencies and setting up the environment such that your software can run efficiently and in a smooth manner and can be installed in a smooth manner. And with the advent of releases and software updates or feature releases, the need for uninstalling a software as well as upgrading it constantly based on what is already available or the current state of the system also needs to be taken into account. That's where the package managers have been developed by various software languages or platforms that were available. And to begin with, the oldest known packaging technology is DPKG by Debian and RPM from Red Hat. These were the first technologies that introduced the package management concept. And soon, many other core programming platforms like Maven, Gradle, Ivy have also evolved. And here are some of the examples that I have in the screen, some of the logos associated with the various package managers. As a conclusion, a package manager will help you manage the software in a consistent and efficient way. And it will also make sure that all the data associated with your given software, like your dependencies, your configuration, as well as the metadata associated with your software release is all in one place and can get installed in a given system. Let's quickly check if there are any questions in the chat. Okay, looks clear. Let's move it into the next slide. Now, where does a binary repository manager comes into the picture? Now, it's kind of a software hub that simplifies the development process for different teams and the different software technology stacks that you might be employing to develop your software application in your organization. For example, uh, let's take as an example, there's a ride-sharing technology company. It might have a web application, it might have a mobile application, it might have certain production servers running the core technology of maintaining the database around what are the passengers, what are the taxi drivers that are online, for example. So it can vary between the devices and between the technology stack. Multiple types of packaging technologies might be employed. For example, NPM for or Node.js, JavaScript for web application front end, whereas Maven for the backend technology, as well as their mobile application might be built in iOS and Android platforms, so they might be using Cocoa pods and Swift repositories for the same. So you can imagine when a given organization is looking to develop software application, it is not just limited to one single technology or one single programming language. It can vary between the organizations and between the teams within the organizations as well. So having a single solution or a software hub that maintains the repositories for all of the packaging technologies that are being employed is going to be really helpful, because it will become as the single point of reference for all the teams in the organization. So we'll talk more about it, and we'll also see how a binary repository manager can help you organize these artifacts, the explosion of artifact growth that you're going to have in your organization. So something to keep in mind, you might be wondering what a software artifact is. It's kind of like an umbrella term for all of the byproducts that are associated with your software development process. It can be an executable, a source code, a dependency, or a binary, or any other resource associated with your given software application can be called as an artifact. And the same way you have, for example, any inventory management system or a repository management system, you have a software to manage the list of or the database of entities that are being stored inside a given inventory or a repository management system. Same way for a software development artifact or a software artifact, you will need a repository management system. And that's where a popular solution called JFrog Artifactory comes into the picture. Again, we'll dig deep into what JFrog Artifactory offers and what is unique about JFrog Artifactory as a whole. But this is also something that as a prerequisite, you will need to be aware of as a developer in the DevOps world, what a software artifact is about and why do you need a binary repository management system or a software artifact repository management system in your organization. Now, when it comes to the definition or a quick introduction about Artifactory, it is universal in nature. Remember the fact that a given organization can develop software in multiple packaging or application stacks. So having Artifactory as a universal binary repository manager, you can make sure that no matter what the software development stack your developers are developing the software in, whether it might be Java, Python, C, C++, Linux Debian, Linux Red Hat operating systems, we have a repository to store your artifacts under. And for any other artifacts that are outside the standard packaging technologies, we also have a generic repository where you can store artifacts of any file extensions. So a total of 27 plus packaging technologies are supported. And we also support full metadata integration, how a given artifact is being utilized, what kind of test qualification criteria has it met in order to qualify it to be deployed into production. We maintain the entire system of record from the inception to the testing to the deployment, and even while the artifact is running in the production, we maintain the metadata around its qualification and consumption levels. That's where you will have a better organization, and you'll get all the benefits of DevOps using this universal integration as well as universal support for various packaging technologies. So in order to answer the question on why you might need a binary repository manager to manage your software artifacts, you will need to see the entire DevOps workflow and the various stages involved. Typically, when we see an organization that is implementing DevOps. So first, the developer puts in all the code changes or commits the code changes into the version control system. The same way you have a version control system to store your source code rather than storing the text files in some storage space, you will need a binary repository manager to store the binaries. Because if you look at the next stages in the CI/CD or DevOps implementation, you are basically having the build or the CI tool that that performs the continuous integration and the build process in order to convert the source code into a binary or an artifact. And this artifact gets passed through various unit tests, functional tests, performance stability tests, and finally gets deployed into staging, pre-production, UAT environments before it gets delivered into the final production environment. So you can see the first stage is scanning. The next stage is a binary repository manager, and then you will have several other Docker Compose steps that will basically build out the entire application stack or microservices and deploys the given application. There might be end-to-end tests involved, there might be distribution or delivery process involved, and there might be deployment that gets done into multiple environments before it gets deployed into production. So all in all, over the entire process of the CI and the CD, continuous integration and continuous delivery, the artifacts or the software binaries or executables are being exercised all along the process. And by having a repository manager storing them and serving them is going to make sure that there is single point of reference, and all along, while these artifacts are being accessed or your software applications are being accessed by each and every system in your DevOps implementation, we are actually collecting the metadata through these systems. For example, here, the white dotted lines represent your regular CI/CD workflow, whereas the green dotted lines here represent the universal integration that the universal binary repository manager is performing here. And these integrations can be through REST API, can be through JFrog CLI, a native package client that the given packaging technology offers. For example, there's Docker CLI for Docker, NPM client for Node.js or JavaScript. There can be apt-get client for your Debian packaging technology packages. When you perform apt-get install networking manager, basically the apt-get client is connecting to an apt server or Debian package server to pull the package and install it on the given instance. So similarly, your entire CI/CD workflow, your developers build IDE systems might be pulling in multiple dependencies during the local build process or during the CI build process. Every time there's a request for a certain package, the given binary repository manager like JFrog Artifactory can serve it to your organization. And there are various types of repositories as well. And each packaging technology has its own unique set of protocol that needs to be followed to index a given package and make it as a part of the search inventory that the users can utilize. We'll talk more about it when we switch to the demo unit. You might be wondering that, hey, why do I need this binary repository manager in terms of scalability purpose? Because any other storage solution can also offer search capability, and why can't I store it in a traditional cloud storage provider solution, like a cloud storage solution, in order to serve my artifacts? We have also seen various entities using some sort of an NFS shared drive or some sort of a version control system even to store their artifact. But when it comes to a given software artifact, the metadata is the key in order to determine whether the given software artifact is ready to be deployed or not. A binary repository manager like a JFrog Artifactory will be able to maintain the full metadata around the given artifact's consumption. And this metadata is of 3 types that Artifactory maintains. The first type of metadata is the information about the inception of a given software artifact. For example, you might have a quick build process. For example, the popular CI tool that we know about, which is Jenkins, as an example. It might be creating a given software artifact. Here, the pipeline is step 3B, create Docker multi-app. And this pipeline is basically producing a Docker image at the end of the day. Now, what are the dependencies that the given Docker build process has consumed? And what are the build conditions, like the system environment variables, that depict the tool set that has been used while composing the given Docker image is also captured in a JSON format file and communicated back to Artifactory. And Artifactory not only just stores the artifact, which is the Docker image, but also the metadata associated with it, using which you can also refer back to the metadata and search the metadata as you wish. Now, if you look at this build process, the given Docker image has been produced. And let's take a look at the same Docker image inside the Artifactory instance. So let me log in. So here I can see the same set of builds that the build pipeline has produced within the Artifactory instance as well. So the entire metadata about the inception of the given artifact has been captured by Artifactory. Here I can see the published modules, which is the Docker image, the number of artifacts and dependencies that are part of the given build, and the system and environment variables that also showcase what sort of rule set has been utilized while composing the given build. And this is something that I can refer to as well as share with my developers, because the same source code might not produce the same artifact if you build it again, due to the varying build conditions or due to the varying transitive dependencies as well. So having the record maintained will help you to recreate the conditions as well as maintain the system of record. Again, we also maintain the security information about the given Docker image or given software artifact. What does it comply with in terms of licensing and security vulnerabilities, as well as operational risks associated with the given dependencies that it has ingested. All of this information is also captured. Of course, this is not our focus. We'll also be switching to the issues. We can also capture the various issues from your Jira ticketing system or any other ticketing system that you might be using, the list of bugs that have been fixed in the given release. All of that information can be captured from the CI tool and published back into Artifactory. The most important capability is finding the diff between the builds. For example, your build number 99 has passed through all the tests, whereas the build number 123 is failing certain integration tests. You can quickly find the diff between the builds to see which Docker layers have been updated, modified, or removed, or remain unchanged. And at the same time, what sort of dependencies have been introduced newly, as well as remain unchanged between the builds. What I also like about this is if there's a Java version that has been modified or the runtime environment that has been modified between the builds, you can also see that information out here. So for now, I see that the Java version is almost the same, but I think the Java runtime has been upgraded. So this is something that will help you immediately flag this issue. And this will be a good handoff between the release engineer as well as the developers as well, because they can access the same information and see what has changed between the builds and figure out what is the best course of action that they can take. And you can also see the release history, effective permissions. One of the important aspect of having the binary repository manager is to make sure that you have fine granular access control or RBAC controls, because there can be hundreds of team members and thousands of software applications that are being developed, and you want to make sure that a given team member cannot access the software assets outside their purview or outside the scope of what they need. So you can use our fine granular permission model to also control the list of RBAC controls each user can have within the system. Now you can also view the details around the version control system. What is the Git system, Git commit that has resulted in the given build. And all of the information that we have accessed in these tabs is also available as a quick JSON format file. We call it as the software bill of materials. By the way, you can also export your SBOM from Artifactory in SPDX and CycloneDX formats, especially with the cybersecurity executive order that came out last year. This is really helpful for our federal customers as well. And of course, if you're looking into embarking on maintaining the software bill of materials and producing it for your auditing purposes, this is also something that you can take immediate advantage of. I see there are a couple of questions in the chat. The first one is, so artifacts are any piece of code that is about to be updated to the production environment? Yes, it can be any piece of code, any piece of executable binary or an object file, anything that is associated with your software release. Yeah, again, a software artifact can be pushed into any environment because you might have multiple stages of qualification in your organization: dev, QA, staging, pre-production, and production. So the artifact will travel all along these stages before it can be qualified to be deployed into production. At each stage, you can determine whether the given artifact has met the required promotion criteria, and based on the criteria that it has met, you will be promoting the artifact to the next stage. And before you promote the given artifact, you might tag it with a property called QA equals to passed, or QA equals to failed, or sanity test equals to passed, or sanity test equals to failed, for example. So using this promotion criteria, you can maintain the metadata, and you can qualify or disqualify a given artifact to be promoted to an upstream environment or not. So that's where the second type of metadata comes into the picture, which is the custom metadata that you might tag a given artifact with. And as a binary repository manager, Artifactory supports multiple types of tagging. You can have single select, multi-select, or text-based key value pairs tagged to your given artifact. And there's no limitation as such. You can tag a given artifact with unlimited properties. And we also support property sets, using which you can create a template of properties that the developers can assign to a given artifact, and using which they can describe the promotion qualification status of a given artifact to the downstream users. This is also part of the handoff that you can provide to your developers, to your release engineers as a part of this DevOps implementation. If you're looking more to learn more about how to work with JFrog custom metadata and the properties associated with it, you can refer to this document. We'll be sharing this offline post the webinar. And you can also see how this property tagging can be done through the UI as well as the REST API, and how the property sets can be utilized in terms of consumption. We have a very robust query language called Artifactory query language, using which you can search through the entire set of full metadata that we provide integration with. One of the implicit property that we maintain natively without the need for any operations on your end is the statistical metadata that Artifactory maintains. This can be total number of downloads, who uploaded it, who downloaded it, who modified the given artifact. All of this metadata can also be captured by Artifactory and can be maintained within Artifactory. So a further extension to our previous universal integration diagram, of course, we might not be able to dig deep into each and every step here. This is the 11-step diagram of Artifactory that showcases the universal integration capability that it offers and the various advantages that you can gain by using a binary repository manager in your DevOps workflows. As a quick overview, here on the left-hand side, on the step 1 to 3, you can see a developer. This is, I call it as a local development environment. A developer will be pulling in multiple dependencies in his or her local development IDE or build system. And generally speaking, they use a packaging client that is associated with the software technology that they are building their application in. For example, if they are developing in Python, they might use a PyPy client to pull the Python dependencies from the internet. Now, all of the publicly available open source dependencies are saved in a open source registry or a private registry, depending on what type of dependencies that you're relying on, first party, second party, third party. Now, a given developer typically pulls the dependencies from a publicly available registry for open source dependencies. By using a repository called remote repository inside Artifactory, you can proxy cache all the remote dependencies that your organization is relying on and store them locally inside your Artifactory instance, only the artifacts that are demanded by your developers by using a remote registry. So for the various 27 plus packaging technologies that we support, you can create a remote repository specific to the given packaging technology and start having your developers cache the specific set of dependencies that they're consuming from the internet within Artifactory. And as a next step, again, if you're looking to control the software supply chain, you can also disable the access to the internet, wherein every pull should be coming in through Artifactory, and you have a good traceability and accountability between your teams on what set of public remote dependencies that they're relying on, as well as the sources that they're relying on by using this workflow. So let's switch to the demo unit and take a look at how this happens in action. Okay. So this is my Artifactory instance. As soon as I've logged in, I can see the various packages, builds, artifacts that are being published into the system. Let me refresh the window a little bit. So if I go to the administration tab, here I will find all the repositories that are being served by the given Artifactory instance. Here I can see there are 3 types of repositories. First, I will talk about the remote repositories as discussed. Once I click on add repositories and choose the remote repository, it will immediately populate all the 27 plus packaging technologies that we support. We recently introduced Swift packaging technology manager, as well as we have introduced Rust cargo packages, And we have also introduced Terraform repositories as well. So these are some of the newer technologies that we have introduced into the system. And this list keeps on growing, again, depending on the popularity and the usage of the given packaging technology. We have various types of repositories that you can rely on. For example, if I click here, PyPy, immediately a remote repository creation menu will be populated, and the most popularly available PyPy registry will be available. I can just name it as Team A Python remote registry. So from now on, my developers can use this Team A PyPy remote repositories URL to start consuming the public dependencies from pythonhosted.org. So for example, this is the Team A. So this is the various remote repositories that are created. And if I click on one of the JFrog PyPy remote registry, I can click on Set Me Up, and I can type in my credentials. Give me 1 sec. And immediately I'll be given information on what are the sets of commands that I can insert into my PyPy client to start downloading the dependencies that I need. And the snippets associated with the same are also available, of course, if I type in the password. Now, if you are newly onboarding Artifactory and wondering how to quickly get started, there's also an option called Quick Setup or Quick Repository Creation. Here, you'll be selecting the packaging technology, and immediately it will populate all the 3 types of repositories that you will need to start developing your artifacts using this packaging technology. The first one is the Alpha PyPy local. For example, in this case, a local repository, as the name sounds, it is local to your given organization. This is where you store your local proprietary artifacts, local to your organization, and cannot be something that is available in a public registry. This is your own proprietary information or proprietary artifacts associated with your software application. It is also creating a remote repository that is proxy caching the pythonhosted.org. This is the Alpha PyPy remote. This is where any remote dependency that you need from the public registries can be pulled in. That's why it is called a remote repository. And the third type of repository is a virtual repository that can simplify the onboarding process for your developers. Essentially, you might be relying on multiple remote sources. You might have multiple local repositories, dev local, QA local, staging local, prod local, which defines the various storage locations for various types of maturity level of artifacts. So the virtual repository logically aggregates multiple local repos as well as remote repos, as well as any other virtuals that are associated with your organization into one single URL or one single URL or reference point, such that it will be easier for your developers or your CI tools to onboard artifact repositories rather than having 5 different URLs being populated in various locations in your build script. You can have one single URL embedded into your build configuration or build script. Now, even in terms of your software supply chain management, you can also control the sources down the lane. For example, there will be a security mandate by the security team that you cannot rely on pythonhosted.org moving forward, and we maintain a whitelisted repository or a whitelisted source from a different vendor or through a different curation process. You can just have the given virtual repository configuration opened up, remove the public registry, and add the whitelisted or approved repository in a one-click button. so that you can control the sources as well as control the resolution order as well using the virtual repository. That is one another advantage with a virtual repository. And keep in mind, virtual repositories are also security aware or RBAC control aware. So even if you provide the same URL for your developers and for your QA testers, depending on the permission level, which repositories the given QA tester has read privileges to, only those artifacts will be resolved for a given QA tester. They can only view the QA test candidates, for example, whereas a developer can view the snapshots as well as test candidates. Same goes with the ops team member. If you provide the virtual repositories for the virtual repository URL for the ops team member, and the ops team member has only access to staging and prod repositories, he or she only will be able to see staging or release candidates. Okay. So that's how virtual repositories can be utilized. And always, I recommend you to use the set me up option to configure your packaging clients to work with your Artifactory repositories. Here, the same alpha PyPy virtual can be clicked on, and click on set me up, and you will see the configuration information accordingly. So you can see the full inline information out here. Okay. Let's go back to the presentation quickly. So the next steps are, once the developer commits the changes into the version control system, the CI/CD pipelines will come into the picture. And here, the builds will be much more faster, because rather than the CI tool pulling the dependencies all the way from the internet, here you have a dedicated local registry serving your artifacts, serving your dependencies, third-party dependencies. And this is customized according to your organization needs, because rather than having millions of packages and hundreds of terabytes of data being cached, we're only caching certain percentage of the public registry that is only requested by your developers in the first place when they perform the local builds in their dev environment. So now the dependencies are quickly resolved and you will have faster builds. This is also important to have faster builds in a DevOps world, because the more the number of iterations that you perform, the incremental releases that you deliver will need to be faster. If a given build takes 20 minutes to get built, you are basically being hindered by the delta or the time being taken for the given build to happen. Whereas if your builds are faster, you can make sure that your continuous releases or continuous automation is not having any bottleneck in the process, and you get immediate results as you push the changes into the version control system. This is also something that I have seen organizations are placing a lot of emphasis on nowadays. Now, finally, once the final artifact has been built by the CI tool, we collect the bill of materials in a JSON format file. And along with the actual artifact, we maintain the software bill of materials and the full metadata associated with your given artifact in the local repository, as we talked about. Okay, so there is no need for you to publish your artifacts into a public registry or a public registry that also serves a million other users. You have your own dedicated registry built for you and working for you, available, catering all of the packaging technologies that you are employing in your organization. So you don't need to maintain multiple solutions and multiple servers in your organization, one single source of truth for all of your artifact needs. Now, the next two stages are pretty much straightforward. You'll be performing multiple tests on your given build before you qualify and certify the given artifact to be deployed into production. The number of stages here can vary. The list of tools that you employ can also vary between the organizations, but the automation is the key, right? Automatically picking up the latest build and performing a series of tests, and then making sure that the metadata is captured all along the process, and the builds are promoted accordingly from one local repository to another. For example, I would recommend you to create 4 set of local repositories: dev local, QA local, staging local, and production local, so that you can have the series of repositories that can maintain the maturity level. And as the given artifact passes through the given criteria, you can promote the artifact to the next set of stages. And finally, your deployment orchestration tools can deploy the artifact into the production server once the artifact is available in the production local repository, right? And using the AQL, you can also further simplify the list of test candidates, staging candidates that the automation tools can pick up and work on, and tag the artifact with the latest updated status accordingly. And mainly in terms of storage and retention policies as well, this can be really helpful, because you might want to retain your production release for more than 10 years. You might want to get rid of your snapshot build candidate within 10 days, for example. So as the organizations develop more and more software and produce more and more releases to ensure the best practices are met and the incremental feature releases are built, it is really essential to also control the storage growth in your organization. By having all of these best practices in place, you can also make sure that your binary repository manager is serving more than just a storage capability, but it is serving your full metadata needs and organizing your artifacts efficiently and serving you the artifacts whenever you need quickly with the robust search capability using an AQL criteria, for example. So you no longer need to scramble around, searching for a needle in a haystack. We are simplifying the process of managing your repositories using this approach. So I think we have already covered this demo on how to perform a quick repository setup inside Artifactory and get started with Artifactory. There are more and more advanced webinars as well, both for Artifactory, as well as we also have a dedicated webinar for our product called JFrog X-Ray, which will ensure the software supply chain and showcases various reports around security vulnerabilities, licensing compliance issues, and operational risks associated with the open source components present in your software application. More recently, we have launched something called JFrog Advanced Security Pack that also includes application contextual analysis, secrets detection, application service exposures detection, so that once your artifact is in a final state in a containerized format, such that it can be deployed into the production, you can also qualify if there are any misconfigurations, bad practices are in place for the given Docker container application, so that you can be aware and make some remediations. We also provide remediation steps as well in the given tool. That is something that you can explore offline and explore our follow-up sessions as well. By the way, I have a workshop on JFrog Advanced Security coming up on Wednesday. Feel free to sign up for that as well. Now, conclusion, Artifactory being a universal binary repository manager and DevOps being the center of software development activities nowadays in the organization, you are going to need automation, and this is going to be critical for your success. And JFrog platform as a whole, with the Artifactory as the centerpiece, can help you manage the software chaos and organize the binaries in an efficient manner, and can control the RBAC as well as maintain the full metadata around a given artifact, and can be a single point of contact or single source of truth for all of your devices, servers, teams, and customers, even for your developers, release engineers, build engineers, ops teams, DevOps teams. This can be a very good tool to hand off the information between the teams and between the environments, and make sure that there are a good set of principles that are being followed for a given artifact and manage its entire life cycle inside your organization. Now, there are other set of tools as well in the JFrog platform, like JFrog distribution that can streamline the process of delivery process and can create atomic tamper-proof release bundles for your end customers. It can be internal users or your external customers subscribe to your software updates. We have a solution called JFrog Connect that can deliver software updates to your IoT devices, especially running on Linux operating system. We have a CI/CD orchestration tool called JFrog Pipelines that can be a good alternative for your existing traditional CI tool like Jenkins, for example, completely YAML-based configuration and supports static and dynamic node pools. We also have some JFrog Insights and JFrog Mission Control that can be a command and control center that can monitor the system health and performance of various systems that are present in your JFrog platform. So if you are interested, you can sign up for those follow-up webinars as well. We have covered today the introduction about what a binary artifact is about, what a binary repository solution, and why is it important to have a binary repository manager in your organization, some of the quick first steps to get started with JFrog Artifactory, which is a universal binary repository manager, and how it maintains the various information points about the artifact's inception, consumption, and promotion qualification criteria, and how you can consume the information as well. Thank you all for joining me today, and looking forward to our webinar on Wednesday.
And thank you, Gautam, for this beautiful webinar. And please, as Gautam suggests, don't hesitate to get in touch with us. Thank again to everyone.